Hello, now we are going to look at the different ways or the number of ways that we can arrange things or put groups of things in order. So we could be talking about lots of different examples. These questions can be phrased in lots of different ways, like the books on a shelf, but in this case, how would we arrange the letters in the word maths? So we have M-A-T-H-S. How would we arrange them if there was no restrictions? So we can arrange them however we like. So we can imagine that we have pieces of paper that we've cut out and we have a letter on each one of those pieces of paper. How many different ways could we order those letters? If we put them down, the pieces of paper in lots of different orders, how many different ways could we do that if there's no restriction on the way we order them? Well, if we imagine our pieces of paper, we can actually draw boxes to help us keep track of our options. It's a very good habit to be in, to draw boxes. So I have 5 letters, so I need 5 boxes. And how many options would I have for the first letter I put down? So I have these pieces of paper with the letters sitting in my hand. How many pieces of paper, how many options do I have for the first letter that I put down? Well, I would have 5 options. I have 5 pieces of paper in my hand, so I can put any one of those down on the table as my first letter. Then I'd have 4 letters left in my hand for my second piece of paper that I put down, and 3 left, and 2 left, and the last one isn't really a choice. Whatever letter I have left over at the end is the final one I put down. So I only have one option for the last letter that I put down. So here I have 5 options, and then each one of those 5 options, from each one of those 5 options, whichever letter I pick first, I'd then have 4 other letters that I could pick from, and so on. So we know from our fundamental principle of counting that I would have 5 by 4 by 3 by 2 by 1 options available to me in total. So that's the number of ways that I can arrange my pieces of paper on the table. Now we can kind of see a pattern here. We have 5 by 4 by 3 by 2 by 1. This actually has a special name in maths, and it's a button on our calculators as well. It's called 5 exclamation mark. The exclamation mark is called factorial. So factorial for our exclamation mark in maths. And as I say, it's a button on our calculator that can save us a little bit of time, but we can also just multiply all of these numbers up together and we get a total of 120. So if you put 5 factorial in our calculator, or we do 5 by 4 by 3 by 2 by 1, we'll in either case get 120. So that's the total possible number of ways that we can put those 5 pieces of paper down. Now, we can have restrictions that make this story more complicated, but if we use our boxes to keep track of the options we've got, it makes life a lot easier. So I'm going to draw my 5 boxes again to help me keep track of the restriction that they've given me in this second part of my question. So how many ways could we arrange these letters if a consonant must be first? So a consonant is a non-vowel. So we only have one vowel in maths, it's the A. So we'd have 1, 2, 3, 4 options for our first letter. So our first letter has to be a consonant. So we'd only have 4 options available to us. We could only take 4 of those pieces of paper, the M, the T, the H, or the S, and we could put any of those 4 down for the first letter that we put down. But after that, we can do whatever we like. Whatever letters we've got left, we can put them down. So how many options do I have left for my second letter? Well, I still have 4 pieces of paper in my hand. I only used one of those letters when I put down my first letter. So I'd still have 4 options available to me, and then 3 left, and then 2 left, and then 1 left. So then I just multiply all of that together. I'd have 4 by 4 by 3 by 2 by 1. And I just multiply all of that out, and I get 96. So I have 96 of these. So this is still a part of the 120 group. So of the 120 possible ways of doing this, 96 of those times when I randomly put down my letters, I would get a consonant first. Now another restriction, if a vowel must come last. So I draw my boxes to keep track of the information I know about. I have my 5 boxes for my 5 letters. 3, 4, 5. So a vowel must come last. So I deal with my restriction first. So I'm going to fill in that piece of information first. So how many options do I have for my last letter? Well, I only have 1 because there's only 1 vowel in the list. And now I can fill in my information as before. So now I have my restriction dealt with. I can say, well, how many letters do I have left for putting down the first letter as I have it written down here? So that means I only have 4 letters left that I can choose from. I just have the consonants left, the M, the T, the H, and the S, because I've just put down my A for my last letter. So I would have 4 options here. And then 3 letters left, and then 2 letters left, and then 1 letter left. So I'd multiply all of them together. I'd have 4 by 3 by 2 by 1 by 1. And I would end up with 24 possible outcomes for where the vowel is last. Now, how many ways could I do this? How many arrangements could I make if TH must come together? So the letters T and H now come as a pair. They're going to move around as a unit. So what I'm going to do is write my 5 boxes to keep track of my information. But I'm going to put a box around 2 of them. It doesn't really matter which one I put a box around. It doesn't matter. I could have put a box around these 2 or the last 2. But I need a box around 2 of them because I'm saying these 2 are going to be my T and my H blocks. And they're going to move around together. So if I think about my T and my H blocks, well, the T block or the H block could come down first. So I'd have 2 options of these 2. I would have 2 options for the 2 letters coming down first, or I'd have whichever one was left for my second option. So that's the way that I could order the T and the H. So I could have HT or I could have TH, hence my 2 options. Now, this whole unit, the TH block, now moves together like it was one of the other blocks. So I have 4 different places that pair could come down. And then I'd have 3 letters left over and 2 letters left over and 1 letter left over. So I have 4 options for where TH can sit in my group. And then I have the cards that are just left over. And inside my group TH, I have 2 options for where the first card comes down and 1 option for where the second card comes down. And combining all of that, combining all of my options, I'd have 2 by 1 for the order of T and H. And then I'd have 4 places that could go. And then the 3 other cards go down in descending order, or how many do I have left as I'm going down. So I multiply all of that out, and I get 48. Now, how many ways could I do this if the letters have to be spelled backwards? So if maths has to be spelled backwards. So I have 5 boxes. And how many options do I have for my first box? Well, if it has to be spelled backwards, I only have 1 option. It has to be the letter S. And then the next one has to be the letter H. And the next one has to be the letter T, then A, then M. I don't really have much of an option at all. If it has to be spelt backwards, then I only have one way of doing that. Now I can multiply 1 together 5 times, but logically speaking, I only have one way that I can spell that letter backwards. Now, how many ways could we do this if T and H is not together? So this builds off of work we've already done in this question, because it would be quite complicated to figure out all of the different ways that T and H could not be together. But it's a lot easier to think about, I know about the total number of ways that I can arrange these letters. I can do this 120 different ways in total. And I know that of those 120 ways, 48 of them have T and H together. So to find out all of the ways that T and H are not together, well, all I'd say is I have my total number of ways of organizing these things. And if I get rid of all of the times that T and H are together, then I'd have to be left with all of the times that they're not together. Because they're either together or they're not. So if I remove all the times they're together, I have to be left with all the times that they're not together. And we've seen this type of argument more generally in probability, but we can see it now here in terms of our arrangements. So our total number of ways of arranging this is 120, and then all the times that T and H were together we worked out was 48. So there would be 72 times when T and H would not be together. And that's how we can tell the story of how we arrange things for our probability questions. And that is what we need for now.